Hi, everyone. This is Bobby Harris. I'm the Executive Director of the Utility Broadband Alliance, and it's my pleasure to welcome you here today to our August webinar. We have some really exciting topics to discuss, something new and different, and some new faces for you to meet. While you're all getting logged in, you are in listen-only mode, but remember the toolbox will allow you to type in your questions, and I really encourage you to take advantage of the Q&A time. Type your questions in. We will get to as many of them as we have time for, but certainly don't hesitate to type them. If we don't get to your question, we'll follow up after the webinar in person or one-on-one. So do take advantage of the Q&A section that will save time at the end of the webinar for. You know, as always, we are recording, and hopefully we'll be able to share this with any of your colleagues, but you guys are on live, and that's the most important audience that we want to talk to today. So without further ado, I want to turn it over to our slate of panelists, and for Paul Anuszkiewicz to lead us off. Paul, sir, take it away.
Good afternoon, everyone. Thank you, Bobby. My name is Paul Anuszkiewicz. I'm a board member of UBA. At the same time, I'm the corporate secretary for UBA and the chief operating officer of Palmetto Technology Associates, which is a consulting firm. Today, I've got some distinguished guests. I've got Fabien Petitgrand. He is the CTO of Ubiik, and then I've got Paul Reid, who's the global VP of Global Sales and Marketing, as well as the president of Ubiik's Mimomax New Zealand. One of the things that has happened is recently, and I'm going to be asking Paul and Fabien to talk about this, is the merger of Ubiik as a company and Mimomax. These are two great companies that have been very supportive of UBA in the past and have some great solutions. So it's great that they're putting these two companies together. They closed their merger in July of this year. And again, they're putting the two companies together. A couple of things about both of these companies is Ubiik has now won their fourth consecutive AMI tender in Taiwan. They'll finish their deployment in 2024. This is millions of AMI meters that they're deploying with their weightless product. Also, Paul and his team from Mimomax, pre-merger, they've done a lot of work with a lot of utilities over the last few years to deploy their licensed spectrum stuff around SCADA and also field area networks. So welcome, gentlemen. I'm going to lead the Q&A with each of them, and then again, we would invite all of you to put your questions in the chat so that we can do that. But before we begin the topic, it's probably a good level set to talk about things I've talked about with my clients, things I've talked about with all of the key IOUs here in the U.S. and the co-ops. There is a lot of challenges, and I'm going to ask Fabien and Paul to be able to elaborate on all of these and how what they see that can be deployed in the 915 band in particular, which is about this webinar, and then how this all comes into play. And in particular, I know all of you utilities are looking at cost of how to deploy these private LTE networks, the scarcity of spectrum, and what are your spectrum choices and options, and how is the best way to deploy, and really the challenge in being able to what applications you want to put on what spectrum, and at the same time how you need to mix and match your critical applications around. So with that, I'm just going to open up the questions and kind of really talk about this in terms of, what are the options available to utilities as they do that. So Paul Reid, can you help me, if you wouldn't mind, assist our utilities here with what are you seeing, their communications are going to be within the past decade, but what do you see now emerging in the future in this decade that we're stepping into now?
Yeah, so we've obviously moving through quite a lot of change at the moment, and what we're seeing here now is really the uptake of private LTE technologies is becoming the leading sort of technology. But that's not to say it's the only technology. So when we started deploying our networks, and these were initially, you know, some of the very first field area networks as defined around the distribution grid. There's a transition at the time from serial-based data, TDM-based technologies to IP, and that was driving a lot of what our customers were looking to do. And what that meant is that with also the onslaught of advanced distribution management technologies and systems being evolved, there had to be a plan that was put in place to be able to accommodate the benefits and the efficiencies that the ADMS was proposing to deliver. And on the back of that, what we saw is that, well, a field area network really needed to have a lot of devices in the field, distribution devices connected to really realize the benefit of that ADMS system. So that was driving the initial uptake, and that sort of led itself to larger field area networks that were then reliant on high capacity throughput. So this would have been an enterprise-based project. It would have been you know, maybe a 5 or a 6, 10-year project that somebody, a utility, would be entering into to provide this level of upgrade. And the goal was to be able to connect to all of these devices, transition from serial to IP at the same time, and really recognize the benefit around you know, the spectrum that they were also looking to try and secure. So moving on from there, what we see now is that there's a consolidation of network requirements that are being requested. So it's not so much about having disparate networks, 4 or 5 different radio systems to manage your network, but how do you then consolidate that into one network that can cover a lot of application? And I think that is the promise that private LTE is offering is that type of capability. And when you're looking then at the bandwidth requirements for that, you're looking at what legacy systems are you needing to support, security around that, getting the benefit from the spectrum, you know, rising costs of lease line technologies, etc., end-of-lifing those. So all of that plays really into an enterprise play around what is our future looking like. And so that sort of talks now to the evolution of where we were with our you know, legacy technologies and how we're seeing that play move towards private LTE. And you know, one of the big challenges there, Paul, that I've seen in talking to a number of customers, how do we kick that process off, and you know, how do we generate an ROI around this as well, and you know, how do we bring that together and you know, get the impetus or the you know, everything behind that to be able to support such a large project. So you know, that's some of what we're seeing in terms of the evolution and the change in the market that we've been in.
Great, that's tremendous, Paul. Thank you for that background. So as we're looking, you mentioned private LTE, and I know that's of interest to every one of the folks on our call today, is with the recent rise of LTE, you know, Fabien, you and your team at Ubiik as CTO, you guys are developing a lot of products. I've seen your FreeRun product recently. Tell us about that FreeRun product that, you know, uses the unlicensed ISM band, but also talk to us about what you're thinking and what you're seeing in terms of trends and what you're working on with the FCC, you know, to make sure that you fit into all of the things that Paul has just described.
Right. Yeah. So as Paul described, there is clearly a trend to converge the network requirements, and private LTE and LTE technology has actually matured to a point where it has actually the means to really deliver a lot of those utility use cases. We also recognize ourselves as an AMI vendor that Not all the technology can deliver all the use cases, and that's actually the rationale behind this merger of Ubiik and Mimomax. When you always have to have application-specific wireless communication for very specific needs, very high performance needs. But LTE can encompass a lot of the use cases for utilities, and I would say especially the latest generation of LTE, so namely LTE-M or NB-IoT to some extent, which are actually a great trade-off between cost, performance, coverage, and requirement for spectrum. Because I think the trend for private LTE is very clear. LTE public networks have shortcomings. We, as a AMI vendor, deploying meters ourselves and using, to some extent, some public LTE network, we know firsthand about those difficulties, about coverage or availability, or I would say actually lack of control and lack of ownership. So I think the private part of the private LTE is really not so much about the fact it's private and you can't allow other people to use it. It's more about the fact that you own that network. So you can actually tune, optimize the network for your use case. You are in full control of the network, of the data. So that's the part where I think utility need to have to deploy those long-term projects, as Paul mentioned, over 10 years plus. Now, private LTE is clearly a trend, but we are also very aware of the limitation to access to the spectrum, or capital expenditure, cost of that spectrum to have license band where you could deploy that private LTE. So we are supportive of private LTE all across the possibilities and the bands. So we have indeed released a GoRAN base station specifically for those use cases in the license band, and we will be supporting Enterix band and others. We'll talk about that. But we do also recognize that a lot of smaller utilities do not have the means of acquiring such licensed spectrum, or it's not just available in the market as well, because availability is geography dependent and then capital as well intensive. So that's actually why we're also looking at deploying private LTE in the unlicensed 915 megahertz band, which I believe a lot of utilities are familiar with. A lot of AMI system and legacy system have been deployed using that unlicensed band, which is 26 megahertz of bandwidth. So it is a fairly valuable asset, and actually LTE can leverage that unlicensed band. So there are pros and cons, and we talk about that later on, obviously, of deploying in that band. But the target of that FreeRun, which has now been FCC certified, so it's actually certified, and you can just buy and deploy it as of today in the United States, allows you to run a purely 3GPP compliant LTE network in that unlicensed band, meaning that you can make devices there. And the goal is really to support those customers that cannot have those licensed band and that can still run with a private LTE network in that band.
So help me understand a little bit more, if you would, and help the audience to understand in particular, what are the pros and cons of deploying private LTE in this 915 ISM band here in the United States? I mean, you and I, the last time we spoke, we talked about different interference and coordination issues. We talked about other things. What should be top of mind for the utilities, and what is the pros and cons of this 915 band?
Right. Well, the pros are quite obvious, as mentioned, that it's lowering dramatically the cost and the barrier to entry for running a private LTE network, because you don't have to make that decision as well to purchase spectrum before you can deploy or trial the technology. So FreeRun is available. You can run with it right now. So operating in the licensed band reduces dramatically the initial costs and deployment cost. Gives you access to the LTE technology as we described. So it's a very versatile communication protocol. It can serve a lot of use cases in the utility space, not all, but a lot of them, especially when it comes to connecting a large number of endpoints. So AMI is an obvious use case that comes to mind when we talk about that. And the obvious benefit of the LTE technologies and 3GPP standard in terms of security, scalability, and the ecosystem that exists for those technologies. So it gives easy access to deploying a private LTE network, even you don't have the means to have your spectrum. So that's the obvious benefit of going that route. Now, of course, there are drawbacks. So deploying in that unlicensed band in the current FCC approval gives you access to 3 megahertz of spectrum, very similar to what Enterix would offer, but it is in that unlicensed band, which may or may not have a lot of incumbent system running in your geography. So you might be facing interference from other users. That's the main difference between unlicensed band and licensed bands.
Mm-hmm.
So the LTE technology is actually well equipped to deal with that in terms of physical layer and how it will adjust its power and its data rates dynamically to contend with whatever is the signal quality. But it is still something that you have to work with, meaning that you will have less control over the quality of service running in that unlicensed band. So we think that the best way actually is still for utilities to just try it in their geographies and have a good understanding of what existing systems they might have in this unlicensed band.
Okay, well, great. Thank you for that. Now, Paul, you've mentioned earlier about the challenges that all these utilities face in terms of different capacity, different latency needs, different use cases. You know, what approach would you recommend that utilities consider when they're looking at all of these options?
Yeah, no, that's a great question. And what we see is, and what we've called it is the spectrum of criticality. And it talks to the overall lineup of technologies that support utility communications. And you know, you can look at it from the highest end of criticality, which is really, you start to talk about teleprotection. And traditionally, you know, microwave would be considered the go-to for teleprotection. And if fiber is not available, that's what will typically be the choice. We have been involved in teleprotection linking in sub 1 gigahertz and near line of sight type applications. And that is the sort of the 5 nines, if not more, type of linking requirement that we get involved with. And at that end of the spectrum of criticality, that is the highest requirement. I guess that also talks to latency requirements, low latency, jitter, and asymmetry. And that's what needs to be considered when you're at that end of the spectrum. As you move back down from the highest requirement down towards mission critical SCADA, then you're talking field area networking type requirements. You're at sort of 3 nines. That's licensed channels. Usually, what we've seen is that the utilities have gone out and purchased spectrum to support that type of initiative. And they're sort of deploying a large field area network in that space. In the same breath, that is a private network, and a lot of that could also be covered by a private LTE solution as well. So you've got licensed spectrum, you've got a lot of SCADA-based assets or network-based assets that you're wanting to connect to. There's a high volume of them. That'll work really well in the private LTE space and the license band as well. So as we move further down that spectrum of criticality, then you start to get into AMI, and what we see there from a million meters or more type of requirement. But depending on the utility or the customers that we've been talking to, that is where the revenue comes in, and that's also got a critical component, but not an operationally critical component. And certainly what we're seeing as well is a tendency towards next generation of AMI to be embracing private LTE technologies, because you may also get the benefit of some DA and demand response and other type of initiatives that would sit around that as well. So that's what we're seeing. And then narrowband IoT fits into that as well. So band 103, looking at at that area of that spectrum of criticality, which sort of sits to the lower end, but still providing connectivity to a high number of endpoints. So that could be endpoints that are less critical, but just simply need connectivity, and they wouldn't really warrant the requirement to have a highly mission critical radio sitting at those endpoints. And then we can move further down to, look, we just want to connect to street lights, or we want to monitor many other sensors and things within the network. And so it talks to a number of different capacity requirements, a number of different latency requirements. What are your power requirements or your backup requirements? Are we going to get some situational awareness through these technologies as well, simply by understanding what's being connected and what's not being connected? And a number of our customers are using metadata to understand that as well. So from that point of view, there may not be a silver bullet that meets everything, but a number of copper bullets that really are still required to support everything that's required in utility communications. However, as private LTE becomes more recognized and evolves into the area that Fabien's discussed, then you can consolidate more within those technologies, and that's the trend that we see happening. But coming back to my earlier point, this is really around what is your strategy? What are your long-term goals? What are you wanting to achieve? What are you looking to drive around, whether it be advanced distribution management, energy management solutions, DERMS, and making sure that you've got enough capacity in that network. And that's one of the big challenges, is how do you size that right at the beginning when you're starting to bring this ROI together? What are these endpoints that we're going to be connecting to? Who are the internal customers that are going to be coming online? And then, how do you kind of size the network requirement? Because inevitably that will determine how many base stations we need, and what is our frequency reuse factor going to be required, et cetera, et cetera. So that really lends itself to some solid engineering and study, and being understanding of how that fits in with the overall strategy of the organization. So yeah, it really comes back to understanding that. But early on in the piece, it's very, very difficult to understand exactly what all those requirements are. So usually, there's a spreadsheet that we would use. We would look at all the applications that were out there. We would look at the bytes that would be sent. We'd be looking at the polling rates. We'd be looking at the number of devices, and then we would be looking to size that network, understand what was the capacity requirement, and then knowing that we're wanting to sort of be able to run this for 10 or 15 years, we would be multiplying that number by a factor, and we would use 3 times to be able to ensure that we are deploying a network that is suitable for our requirements in the coming years, given the environment, the growth, and the likely growth of capacity that's required in in that time span.
So Paul, can I touch on a couple of things that you mentioned that I think are key for our audience? You talked about this level of criticality. So what that sounds like to me, and in some of the conversations I've had with Fabien, and I'll bring Fabien back into the conversation in a second, but I wanted to touch on 2 things you said. This, again, this level of criticality in terms of use cases. So what you're thinking is not one silver bullet. You're thinking, like you said, 2 copper bullets where you would use licensed spectrum for one piece of that puzzle, but if it's lower down in the level of criticality, you would use 915. Is that correct, Paul?
Yeah, that's correct. So we already do that. We already utilize ISM band technologies for metadata and AMI back, AMI data. So that is typically what's happening. I think that also, utilities, many of them have gone out and they've got spectrum and they've deployed a large SCADA network that is in some form of license band, whether that be an FCC licensed band or whether it be in a band where they've purchased spectrum, whether it's 700, whether it be 900, whether it be Enterix, you know, wherever it will be, there is already an element of utilizing licensed spectrum for more critical operations. And then as we move outside of that, there is an acceptance of utilizing unlicensed technology or unlicensed band in those less critical environments. In some cases, there are a number of utilities that are quite comfortable using unlicensed spectrum for more critical operations. And it may be that the alignment with the technology, the alignment with budget, etc., has been able to lend itself to that. That's worked quite well for them, depending on, you know, where they are in the country, and you know, they've been able to operate like that. As you know, so there is dependencies around environment, geography, population density as to you know, where you will tend to operate. But to answer your question, Paul, yeah, there's already you know, licensed spectrum that's being used for critical operations. That's typical, and then unlicensed spectrum is being used for things like AMI and streetlights and other things that have been going on.
Okay. So then you don't see, Paul, to touch on this one last question, for utilities that are just stepping into this private LTE journey, you don't see a problem with operating networks with two different spectrums, and there's not a lot of difference in the architecture. Is that correct? And I'm going to ask Fabien to weigh in on this in a second, but in your mind, it's a good idea for utilities to consider using both the licensed spectrum and the unlicensed spectrum to cover the gamut of the use cases. Is that correct, Paul?
Yeah, I think that's fair to say, you know, but it depends on their situation. You know, if they have no licensed spectrum available, Paul, then, you know, unlicensed spectrum may be the only option for them. But yeah, there's nothing wrong with looking at you know, a hybrid solution by where you may be using a licensed component, and then you're also augmenting that with unlicensed, depending on what the application is and depending on the criticality of that application. And I think this is one of the benefits of what Fabien was talking about with the product that Ubiik have brought out in the unlicensed band, is that, you know, it is giving a lot of capability in that band, but there's nothing to stop that being augmented with a licensed approach also.
Well, that's great, Paul. So Fabien, if we could turn the conversation a little bit back to you. You talked about the pros and cons of this 915 spectrum architecturally, and how easy is it to run a hybrid network using licensed spectrum and this 915 band? And what are the things that utilities should be thinking about in terms of, is it a multiple deployment? Is it just plug and play with two different bands with two different radios? Or how should utilities think about that?
Right. So yeah, well, first I'll also just bounce on what Paul mentioned indeed about criticality, and also comment that it depends how you define criticality, because indeed in use cases like teleprotection, where you do need to guarantee a low latencies, and actually LTE will not be the solution, no matter it's in a licensed or unlicensed band. Actually, you know, when you want to have less than 3 millisecond response times, and actually that's what some Mimomax products are able to deliver in narrowband channels, LTE will not be the ideal solution for that. But when we talk about deploying like AMI, for instance, in the unlicensed band, we say it's non-critical in the sense that it does not have those super stringent latency requirements. It doesn't mean that you are not able to get your data out. So, you know, unlicensed band will allow you to get 95, 96% more readings of your meters. It's just you will have more variability in how much time it will take for each meter readings to come back. But LTE actually will still, in most cases, outperform existing proprietary or semi-standard unlicensed band technologies that have been deployed traditionally for AMI anyways. Now, in terms of hybrid network and different deployment schemes that you touched upon, I think that's actually probably the best way to do that. because licensed band give you the quality of service, but they have a cost. So we do see FreeRun being used, of course, just as a complete alternative to having a licensed band if it's not available, like Enterix or others. But it could also be a complement. So for instance, this radio, the FreeRun that you can deploy in that unlicensed band, can use cellular as well. So it can use LTE as the backhaul, meaning that it can be totally standalone, even with no wire, except it does need to be powered, of course. Meaning that you can backhaul that base station traffic over a licensed band, be it band 103 or Enterix band or others. So you keep the control over the whole network, but it allows you potentially to offload some traffic, say the AMI system, totally on the unlicensed band, keeping a LTE network. So keeping all those endpoints exactly the same, because endpoints that can connect on the Enterix band will be able to connect on FreeRun. So you could even have devices that will select whichever network is available around them. So you can totally have a deployment that is, for instance, in the Enterix band, and use FreeRun to offload AMI traffic or to fill gaps of the Enterix band. That's totally possible. And from the user, so the utility perspective, it's really transparent, because that's just a low-level configuration of which band it is scanning and which band it is connecting to. But all that eventually is abstracted, and those are all IP endpoints, IP addresses that can be supported IPv4, IPv6. So in the end, it doesn't really make a difference from the user perspective.
Right. So can you give our audience an understanding also about how much can you scale this? How can you use this in the 915 band in terms of number of endpoints, but also how can you maximize that use of the 26 megahertz worth of ISN band spectrum that you talked about earlier in the webinar?
Right. Well, so when we talk capacity, it's always very, very dependent on how much bandwidth and how much spectrum you use, right? So actually, LTE could be deployed in different channel bandwidths. And what FreeRun in the unlicensed band currently allows under the current FCC certification is a 3 megahertz bandwidth. So it's equivalent to the Enterix 3 megahertz licensed band as well. And in that, for typically a AMI deployment, you will actually run that as a LTE-M. So LTE-M is one of the latest flavor of LTE, which actually provides better coverage than the traditional LTE, and is part of the 5G roadmap as well. So it is a more future-proof technology, and that's a technology of choice for meters, be it water, gas, or electricity, because it also provides some power-saving features. So in terms of capacity, it highly depends, obviously, on what kind of coverage and range you want to achieve, because there's a trade-off between how much penetration or range you can achieve, which is achieved through some repetition, and the number of endpoints you will be able to service, because then your throughput will drop whenever you have repetition, and a trade-off with as well how often you send some data. So fundamentally, on a 3 megahertz channel, you will have up to around 100 devices that can communicate simultaneously, meaning they are really communicating at the same time on the same channel simultaneously. So then how many endpoints in total your network can have on that base station will mostly depend on how often they send their data. So if you talk about meters that are sending maybe frequently, like every minute, then you will be in the hundreds of endpoints. If you talk about meters that are communicating every 15 minutes or even 30 minutes, then you will be more in the thousands of endpoints that you will have to be able to handle. Keeping in mind that actually how LTE works is when a device wants to send some data, it has been idle for a long time. It will actually send a request to the base station, say, okay, I want to establish a connection now. It will have a channel assigned to it, and then it will be able to exchange data with the base station. And then after a while, on the decision of the device or after some inactivity time, then this channel will be released and the device goes back to an idle state and just waiting for data. So of course, when we talk about AMI, the meter will send a fairly small amount of data. It will expect some acknowledgement back from the server, maybe 2 or 3 round trips at most, and then goes back to idle until the next period or until it's pulled for some on-demand reading or for more exceptional cases, firmware updates, things like that. So it does mean that the number of endpoints that are active simultaneously will never be more than a few thousands or at most 100. So of course they will kind of take turn when they send their meter readings. So in short, you know, if the device is constantly connected, so talk about SCADA or systems that communicate continuously, then you will be in the low hundreds. If you talk about meters that communicate every few minutes or tens of minutes, you can reach into thousands.
That's great. So Paul, how does the utility connect their device to the FreeRAN network? And if we take 915 for a second and we look at FreeRAN, how does the utility actually connect those end devices up into the network? Can you give us a brief, because we're getting a lot of questions coming in, but I'd like to see if we could get you to, you know, describe that for us. Maybe that'll field some of the questions. If not, I'd like to open it up to questions in a few minutes, if that's all right.
Yeah, no, that's great. So yeah, when we look at the gamut of endpoints that are out there that could potentially be connected, so you're talking about still a lot of serial-based devices that are out there. You've got IP-based devices, and then you've got, you know, a number of IoT-based standards as well that are also coming to play. Typically, you know, we're talking FreeRAN, then we're talking devices that will connect to some form of network interface card. So if it was a behind the glass type of meter installation, then a NIC card would be connected to the private LTE component, which would be FreeRAN. And we would have some provisioning for that as well. With the FreeRAN, the core can be built in, or it is built in to the product as well. So one of the differences around what we've been looking at with respect to proprietary technologies that have been typical of SCADA networks, for instance, is a distributed network, which is, you know, IP centric, and you know, you're dialing in with IP addresses, etc. What is different around our private LTE solutions is that we then have a core that, you know, starts to manage that data. In terms of the FreeRAN, the core is built in, or you can also have a distributed, a cloud-based core that would support all of that. So the endpoints, a NIC card can be developed, and that sits behind the glass for the meter or other endpoint devices, or there's other modem type devices that would directly connect. And the nice thing about the ISM band is that it overlaps with Band 8 capable devices. So you already have an ecosystem out there that essentially supports the ISM band private LTE offering. So it's not as if this ecosystem needs to evolve, it's already evolved. So yeah, what we're anticipating that there will be a number of devices that need to be more customized. They will be customized for various meters or other types of devices. And then there will be the generic modem type devices that will simply be able to connect to FreeRAN. And you know, all of these are SIM-based type devices. They'll either be supported by a core that sits within the FreeRAN product itself, or is external. And I guess that you know, the idea would be that the SIMs could connect to both the FreeRAN or public infrastructure also as a backup or a redundant solution around that as well. So yeah, it will be very, very similar to what we do today, except slightly different architecture. And then we'll be looking at, well, what type of endpoints can easily be supported? So what are the polling rates of those endpoints? What are the interface requirements? What are the security requirements associated with that as well? And, you know, the likes of capacitor banks, the likes of, obviously we've discussed meters, reclosers and other things, you know, they can also be supported, RTUs. So it just depends on where in terms of the criticality that sits and what base station that would be supported by. Going back to our hybrid discussion around where FreeRun and licensed technology would sit, you know, you would be looking at those applications and saying, are we comfortable with this in the unlicensed spectrum, versus being more secure around the operational component. And as Fabien alluded to earlier, you know, the GoRAN product is supporting those license bands. So whether it be Enterix or band 103, which is 700 meg upper A block, or other bands that are emerging, you know, that's they're very secure bands. And then you've also got the option of connecting via the unlicensed component as well. So yeah, lots of choices, and you know, quite an easy approach to connectivity, not too dissimilar to what's been undertaken today, with the addition of provisioning for the SIMs.
All right, that's great, Paul. I really appreciate that detailed answer. If it's all right with you and Fabien, I think we've got quite a bit of questions from the audience. So Bobby, if you'd be so kind is to give us those questions so we can have Paul and Fabien really answer the questions that are on the minds of the utilities today.
Yeah, absolutely, guys. Thank you. We do have quite a lot. I'm going to try to group a couple of them together, but Fabien, you spoke a bit about noise mitigation. So the questions here are around how, talk a little bit more about how potential interference from Wi-Fi in the 915 megahertz can be mitigated by Ubiik, and then go a little bit deeper also, it's kind of a two-part question, go a little bit deeper on how that interference mitigation in the 900 ISM band, you know, because it's already pretty congested. How are you handling mitigation? If you can go a little deeper on those.
Sure. Well, so first I will start by maybe just mentioning, so Wi-Fi actually operates, your traditional Wi-Fi operates in the 2.4 and 5 gigahertz band, whereas we are here discussing FreeRun deployed in the 915 ISM band. So this band does not have any Wi-Fi running. So there is no interference from Wi-Fi, but then you can have a large number of still incumbent users. Do you still hear me well? Because I have to...
Yes.
Yes, yeah, okay. So actually there's no Wi-Fi usage in the 915 ISM band. Now you can have other system and license band users. Usually it's more spread out use. Now, in terms of interference, yeah, mitigation of that. So LTE technology by itself actually is more spectrally efficient and more adaptive to the level of noise that it's observing in the band. So, you know, LTE has things like transmit power control. So meaning that all the devices will just transmit at the lowest transmit power that can maintain the link, so that you reduce the overall interference level, and also adjust its throughput and how much coding it will and how much redundancy it will put in the data to recover potential errors during the transmission. And all that is actually a closed loop, so it's continuously adapting to adjust to the quality of the link, which can be changeable. Because LTE is designed for as well mobility, right? So it's actually designed by nature for devices that can move with a changing environment and changing level of noise and interference. So LTE technology, in essence, is very well equipped to deal with that. Having said that, then it is still a wireless technology. So no matter the technology you use, if you have really a large number of users in the unlicensed band, if the whole noise level goes up by some amount, then you will lose fundamentally some range or some coverage from that. No matter the technology you use, if the noise is widespread over the whole band, there is nothing any technology can do about that. So in that case, you will still have a degradation in the range. So I would say that if you deploy in more dense or urban environment where there are more users in that band, you will still end up having to deploy more free runs than you will have to deploy base station in the licensed band. That's the reality. But this has to be looked at geography by geography, because as we discussed, when we are looking at some customers, smaller co-ops or munis, which might be more rural, then actually the noise in the unlicensed band may not be an issue at all. But for some others, it could be a concern, and then we will have to look at the network planning to make sure that it delivers a required level of performance.
Okay, thank you. If I can go on, the next question comes in, and I'm just gonna read it straight out too. Can we use the same UE device for FreeRun in ISM band and GoRAN in the Enterix spectrum?
So the short answer is yes. I'll just go a little deeper on that. So yes, in the sense that FreeRun or Enterix are actually both operating in a 3 MHz slice of the 3GPP band 8. They are just not in the same frequency. So FreeRun would be operating its downlink around 926.3 MHz, whereas Enterix is outside of this band. But any band 8 capable UE or device will be able to connect to Enterix or FreeRun in terms of capability of the hardware and RF component, etc. There is no change required. Now, in terms of connecting to the network, and we did not describe that in much detail. So FreeRun is all the Nokia and Ericssons of the world. That's the base station. And then those base stations are all connected to a core, which is really the brain of the network. And then this actually has an identity that would be the Verizon or the utility-owned private network. And whether a device is allowed to connect to that network or not, then this is actually managed by the owner of that network in the core network and the SIM card on the device. So fundamentally, once the device connects to a network, be it Enterix or FreeRun, then you can think of the fact that the SIM card will be talking to the core network and see if it's allowed or not, and run through the authentication if it's allowed. So provided your SIM card allows you to connect the on the network of Enterix or FreeRun, then your device will be able to connect to both networks. But even more than that, Paul Reid touched upon that. You could have devices which have SIM cards that have two profiles. So it will connect to FreeRun if available. And if it doesn't find it, it can fall back to Enterix or even to public LTE as a last resort fallback. You can think of operating in band 13, Verizon or AT&T as well. So all that is possible. That's, I would say, also one benefit of the LTE technology is that it's very flexible. So you can have SIM and core networks that can talk to each other. So you can have those mechanisms of fallback or going from one network to the other without any hardware change. And the last point I still want to make on that is, even though the hardware doesn't require any change, for a device to operate legally with FreeRun, you will still have to go through the FCC approval for this device operating in the unlicensed band. Because most devices do support band 8, that's actually a very straightforward process. So, but provided you get that FCC approval, yes, any Enterix capable device or any band 8 capable device would be able to connect to FreeRun.
Okay, excellent. So let's talk a little bit more, stay on the device topic. So what are the device capacity constraints in the 915 megahertz bands? So utilities are looking for tens of thousands, probably even more meters. How many meters could a Ubiik GoRAN support per sector? And I know that answer is probably going to be it depends, but let's dive a little deeper into the it depends.
Right, so I think there are two aspects to the question. One is the capacity, I would say, is how much spectrum or how much bandwidth you need to support AMI network. And this question is kind of irrespective, I would say, of whether it's FreeRun or Enterix or others. And the answer to that is that 3 megahertz is more than enough if you use it efficiently to run an AMI network. So whatever is offered in the Enterix spectrum or by FreeRun in the licensed band even more is sufficient to run an AMI network. Having said that, as we discussed, so actually the unlicensed band has a little more restriction than those licensed band. For instance, the transmit power in that unlicensed band is limited to 30 dBm, so 1 watt. So when you actually license a spectrum from Enterix, you will be allowed to transmit with much higher power in that band, which does mean in terms of coverage, you will get less coverage with FreeRun in 3 megahertz than you can get with a Nokia or Ericsson base station operating in the Enterix band. And FreeRun in its current version, because of that 1 watt transmit power limitation, actually is not sectorized. So it's actually by default an omnidirectional antenna. So that provides a lower cost of installation, but it does mean you do not have sectored deployment. So as we discussed previously, you know, if we talk about devices that communicate every 15 minutes, you will still be in the thousands per FreeRun, but you can think of FreeRun as one sector of a traditional base station. But FreeRun by design is still a 3 megahertz bandwidth. It has no further restriction in terms of LTE capacity than you will have on a traditional Nokia Ericsson base station. So there is no further restriction other than the fact that it is limited to 1 watt and to the fact that it does not have sectors.
Wonderful, thank you. The next question switches gears a little bit and goes more towards the CapEx discussion. The question is, would leveraging a hybrid solution of licensed and unlicensed bands increase the capital cost for RAN sites?
Paul, what do you think about that?
Yeah, so I think the thing with what Fabien was talking about is that if we're using a hybrid approach, you've got the infrastructure already there for you know, for your licensed band. Now, there's a couple of ways of looking at that. Is that if you wanted to augment LTE in the in the 915 meg unlicensed band, then that same infrastructure can be there and that can be reused to a large extent. So, you know, if you're operating in a different, you know, you're away from that 900 meg band, that ISM band, then there's nothing to sort of stop you using the same infrastructure. Now, typically what you might also be looking at is as an infill potentially of your existing license band technology, and you could potentially be utilizing FreeRan as an infill component of that as well. Now, FreeRan is the nature of the product means that you're really you're able to mount that on a pole. You know, it's not a tower requirement. So, you know, to get the coverage into a community or to roll that out, it's a lightweight product. It is easily mountable, pole mountable. It can be mounted on existing infrastructure. It's not a whole lot of load associated with that product. It can be run power over Ethernet. So my sense is that, you know, running a hybrid network where you needed to add capacity could utilize existing infrastructure, and you might find that it's actually a more cost-effective option, you know, to be able to embrace that.
Okay.
I may want to add a small technical detail to that as well, because if we take the example of, say, the Enterix band, which is 3 megahertz, then you will typically deploy your more critical devices there. So typically when you deploy on this 3 megahertz, you will deploy for being able to connect legacy LTE devices, you know, talk about phones or higher throughput devices that want to support Cat 1 or Cat 4, even communication. whereas things like AMI and smart meter will most likely be using LTE because it reduces the endpoint cost dramatically and the smart meter cost, and it does provide better coverage. But running both legacy LTE devices and LTE in the same 3 MHz channel is very challenging. And you might find that actually if you want to build AMI on top of your Enterix infrastructure, you will run into those capacity problem and how much capacity you put on LTE, how much on legacy LTE, and how do you do the in-field coverage for this AMI. Whereas actually if you kind of offload a part of the AMI to a FreeRun dedicated LTE network, and then you use Enterix for the backbone and the backhaul of those FreeRuns, then you might end up with a deployment that is more cost effective and actually make better use of the radio resource and with their different characteristics, right? I would say expensive Enterix band, which has higher quality of service, and the unlicensed band, which is less expensive, but cannot support all of the high criticality use cases, but is very suitable for AMI. So, you know, there are some technical details as well when you look at the plan, because LTE is a versatile technology, but you also, you know, devil is in the detail as well. So, you know, what you can do on 3 MHz, etc., needs to be looked at as well.
Yeah, and I think just to add to that, Fabien, would be not just around AMI, but where the FreeRun can augment would be around other low criticality assets, you know, EV chargers, you know, if there was other things that needed to be monitored, basic sensors, etc. So, you know, that's a good point about loading up and how you manage the load on those networks.
Yeah, absolutely. I know we're almost out of time. I've got one final question from the audience I want to get in because it's an important clarification. And I think we want to make sure we leave the audience with this also. Is unlicensed 915 megahertz spectrum for private LTE now available for utilities in the United States?
Yes.
Yes. Just to be clear, the FreeRun product has been FCC certified and is for sale. And as Paul Reid actually explained, it even has the core built in. So, you know, it's also our aim to lower the barrier to entry for accessing private LTE, not just by enabling it in unlicensed band, but also by making it easier to get your first LTE network up and running. So it means you can buy a FreeRun right now, deploy it in the United States legally. It is FCC approved. You can provision your SIM card directly into the FreeRun and connect your devices and get your data directly, your IP traffic out of FreeRun if you do choose to use a built-in core. So you really literally have a network in a box, so you can start testing right away. The product is available and it's certified, so it's legally usable in the US as we speak.
Perfect. Perfect. That's terrific, guys. I hate to stop the conversation. This has been terrific. I know we've had a ton of interest from the audience, as I'm sure we will. For those of you on the phone, we can continue this conversation in Minneapolis at the Utility Broadband Alliance Summit and Plugfest. These guys on screen will all be there. Live and in person, ready to answer your questions, ready to take you on a deep dive. They are doing the Tuesday tech session, so you'll be able to really dive deep with these guys in Minneapolis. So if you haven't registered yet, go to ubbaplugfest.org and get registered. But guys, I want to thank you all for taking the time in all of your time zones to be with us today and share your knowledge. Exciting times for Mimomax and Ubiik. Paul, any final words, Paul Anuszkiewicz?
Yeah, Paul and Fabien, thank you very much for really opening the utilities' eyes of what's available in the 915 band. And again, thank you for your time, and I've really appreciated the opportunity to both get to know you, but also to do this webinar with you. Thank you.
Thank you very much. I've enjoyed it immensely. Thank you, Paul. Thank you, Bobby. Thank you, everyone.
Thank you all.
Thank you, guys. Take care.
Thank you.